Hi. So this is a recording for the resources that I've created for Geodesic domes, and Rana is with me, so we can talk through the resources that I've made. So one major resource is the Anderson book that we have here. Are you aware of this book, Rana? Hello?
Yeah,
Oh,
sorry.
technical difficulties. So the Anderson book goes through geodesic domes fairly well. It is lacking in some areas, so I had to do my own research. But it goes in depth in the octahedron-based geodesic dome and an icosahedron-based one. So those are the two main ones that you need for the leaving cert, and it tells you to what frequency you should go into for the leaving cert. So it's from frequency 1 to frequency 4 is what is required. So this is a very useful resource, and I used it to create my questions and some other resources that I've made. So one of the first resources I made, if I pull up my visualizer, is this model that the students can make in the class. So this model is made of paper. It's has a cardboard base with a hole underneath so that you can see the internal construction of it. And it is fairly sturdy for what it is. It's made of paper and glue. So this will be a fun activity for the students. And I've color coordinated it so that the blue and the red are different triangles. So I labeled them there. So all the A's have the same side, and then the blue has an A and then two B's. So the blue triangles create this pentagon shape, and then that is so this is an icosahedron based geodesic dome, and that is kind of a key element of that type, because the pentagon is the core element of an icosahedron, and the square or hexagon is the base for an octahedron based one. I've also created SolidWorks files. So I have this open, if it opens. There we go. Take a second. There we go. Tell me when you can see it.
Yeah, I can see it.
Yeah. So I just made this model. It's an exact replica of what I made there in person, just on SolidWorks, so that the students can have a virtual side as well. So if I say if we're in quarantine or can't go to schools, I have this model to show them in the video, and I can show them that it looks almost dome-like, like a geodesic dome should. And you can see that the pentagon shapes and the other red triangles are the exact same, and I also have them labeled the exact same way. And then from this, I have these working drawings made so that they're a one-to-one scale, so that I can print out more to make more models, physical models. And then I went off and made this icosahedron. It's difficult enough to rotate in the correct way. So you can see the pentagon base there of the icosahedron. This is a 20-sided dice for D&D, so I can relate that back to the students if some of them play D&D. This is a very simple resource. It's just a 20-sided shape, the exact same triangles. And this is just a model below this geodesic dome, as this is a V2 of an icosahedron. And then for the actual question, I'll show this later on, but this is my resource for the question, so that I can adjust this and it'll adjust my assessment question. And I've also made this. Sorry, it takes a bit to load. I made this resource as well to show the points of contact on the sphere. So if you look at this surface, you can see that there's 2 points of contact, a sphere here and here. And then if we look down, we can see the other points of contact on the sphere. So like octahedral base geodesic dome will have the baseline of 6 contact points, and every time you tessellate those points also a contact. So those are all the resources that I have made myself. Do you have any questions on them?
No, they make it very clear.
Okay. Thank you for listening.